Okay, for the next part of the final exam review, it says right here for problems 8 and 11, we need to name the parent graph, describe the transformations performed, and there's a word bank down here, reflection, translation, vertical, shrink, and stretch. And we also need to draw, this should have said example, of what the graph of problem 8 and 9 might look like. So let's hop over here to problem number 8. So any function where you see x in the denominator of a fraction means that the function name or the family type is going to be a rational function. Like, we know that. And the parent graph of all rationals, so if I take a look at the parent graph, is going to look something like this, where you get two parts that kind of make like little funny L shapes. And this dot right here is at -1, -1, and this dot right here is at 1, 1. So I'll be using that to my advantage here in a moment, but basically we need to talk about what are the transformations. Okay, well, the transformations here. If I compare this pink to the parent function looks like this. So I'm going to put the parent in orange here, just so that I can keep this in mind. That's my parent in orange. I notice that there's a +1 that's attached to the x. So if I look at this in f of x format, I can say, okay, this is f of x plus 1 because this 1 right here is attached to the x, so it needs to be inside the parentheses. And then this 2 up top, well, I know that for fractions, it was a 1, now it's a 2. The only way that I can change this number easily is for multiplying. So that means they went to the very, very, very front and multiplied by 2 right here. So now I know from our studying that this right here is a vertical stretch by 2, and that this +1 right here is a horizontal translation. And then which way does it move? Let's see. Positive, well, that means that it moves left, and in this case it moves left 1 unit. So now the only thing left to do is to actually draw an example of what this would look like. So what I'm going to do is I'm going to take the parent, I'm going to move it to the left 1, and then I'm going to stretch it out by 2. So to show what that would look like, first I'm going to draw my picture here. Now the original looked something kind of like this, and I just cannot seem to get this drawn right today. And not my best drawing of a rational. That's a bit better. Now the first thing I need to do is I need to grab this guy and move him to the left 1, which means he's going to look something kind of like this right here. And this guy also needs to move to the left 1. Let me grab his arrow there and move him to the left 1. Now, remember that rational functions also have these fancy things called asymptotes. So I'm going to put the asymptote right here just to remind me that that's where it was. Now, in the parent, just so that you're clear, the asymptote in the parent was right here. Let me grab the highlighter so we have the same color. It was right here. So what happened was this green line moved over here to -1 just with the rest of the graph. Now we need to stretch this out by 2. Well, remember, stretch means that this dot that was right here actually is going to stretch upward so that now it's going to end up right about here. Same thing with this dot right here. He's going to stretch downward so that he ends up right here. So knowing that, I'm going to erase my original drawing now so that I now have some better control over exactly what I need to draw, and I'm going to be careful not to erase that pink dot right there, and not to erase my black line. And I can fix that part right there. So now I can just say that I know that it starts up, and it's going to come and then go through this pink dot, and then it's going to do that. It's going to start right here, go through this pink dot, and then end up as a down arrow where it gets close to the green but doesn't touch it, because asymptotes are lines that you never touch. And now that's a bit of a better sketch.